Good day, learners. We are back again. Today we are focusing on cubic functions. Remember, from grade 11 you did parabola, which is quadratic. You did hyperbola, straight lines, linear. So today we will be focusing on introducing cubic functions. So cubic functions, let's say our f of x is a cubic. That means our equation is in the form ax cubed plus bx squared plus cx plus d, where your d is your y-intercept. Why is your d your y-intercept? Remember, when looking for y-intercept, you let x to be 0. So let's try it. That means it's gonna be f of 0. Where we see x, we put 0. A into 0 cubed plus b into 0 squared plus c into 0 plus d. Therefore, f of 0, which is our y-intercept, a multiplied by 0 is 0, plus b times 0 is 0, plus c times 0 is 0, plus d. 0 plus 0 plus 0 is the same as 0. F of 0 is what? Is d. That is why we say our d is our y-intercept. So let's move on. Again, you can say your f of x is equal to a into x minus x1, x minus x2, x minus x3. When do you use this equation? When you are given your x-intercept. You can say f of x is equal to a into x minus x1, x minus x2, x minus x3, where x1, x2, and x3 are your x-intercepts. So x1, x2, and x3, they are your x-intercepts. So let's move on. So mostly you are going to use these two equations. So now let's move on to the next concept. So now, since we have introduced our cubic, and we have seen that our cubic can be written in two forms. Now you ask yourself, what is the a in this case? Your a, what does your a represent? Now we are going straight to the cubic. When a is greater than 0, what is happening? Your graph will be like this. Means it will increase, then decrease, then increase. Meaning it will increase twice and decrease once. When your a is positive, what happens when your a is less than 0? Your graph will be like this. So from this we can see that our a determines the shape of our function. So when your a is negative, your graph will decrease, then increase, then decrease. This means that your graph will decrease twice and increase once. That's what you see now. So now we have methods of calculating the x-intercept. Methods of calculating the x-intercept. So in most cases, learners prefer to use synthetic division method, and other learners prefer to use long division. So I will be focusing on these two methods. There are more methods just like inspection, but then I will only focus on synthetic division and long division method. So these are the methods that you use to calculate your x-intercept. And remember, when calculating your x-intercept, you do what? You let y equal to 0. Okay, so now we want to plot our function. we know how to find the y-intercept, and we know how to see the shape, and we know how to find the x-intercept. Then since our graph from our shapes here, from our shape, we can see that our graph has two turning points. So now you ask yourself, how do I calculate the turning point? So when calculating the turning point, you say f prime x is equal to 0. This is the formula for calculating the turning point. The turning point, I'll write it as TP. So when calculating the x values, remember, this formula only gives you the x values of your turning points. So when calculating the x values of the turning points, which is the maximum and the minimum, remember, maximum and minimum. That means that when you derive, you find the maximum or the minimum. So since our graph is going to increase, decrease, and increase, or increase, decrease, or increase, so this means there will be changes. It is going to have a maximum turning point and a minimum turning point always, or vice versa, a minimum and a maximum. So it depends. So when looking for the coordinates of your turning point, you are going to take what? The first derivative, which is f prime x, then you equate it to 0. Then after, what do you do? After finding the x values, of your turning point, what do? For you to find the y values, you don't substitute them in your f prime x. No, that is incorrect. So you do what? You substitute them to your original equation, which is f of x. So after deriving and finding the x values of the turning points, you take those x values and substitute them to your original equation in order for you to find what? In order for you to find the y values. I hope I'm clear on that one. So now we can plot our graph. But then we can see that our graph has two concaves. Remember, our parabola had only one concave. It's either concave up or concave down. So we have concave up, and concave down. So since our equation our cubic has these two things, from this shape we saw that it has concave up and concave down. Where's that shape? From this shape. So how do we know that from here it changes from concave up to concave down? How do we know? What do we call that point? And how do we calculate the coordinates of that point? So we call that point the point of inflection. When they say what is the point of inflection, you can say it's where your graph changes its concavity. So point of inflection is where your graph changes its concavity. That means if your graph was concave up, it is going to change to concave down. So how do we find that? Is f prime of x is equal to 0. That means after finding the first derivative, which is f prime x, you are going to take that first derivative and find the second derivative. You are going to derive the first derivative in order for you to find f prime x. Remember, let me show you a hint. These two dots means that you are differentiating twice. When finding the first derivative is only a single quotation, that means you are differentiating once. So in this case, we are going to differentiate and find an equation and differentiate that equation again. Then we equate to 0 to find what? The x value of the point of inflection. So after finding the x value of point of inflection, you ask yourself, how will I know the y value? Same thing. Substitute your x value to your original equation. You substitute your x value to your original equation to find what? The y value. Remember, what is your original equation? Your f of x. And from this, I can conclude by telling you this. You will see it when we do some examples. Let's go up. Remember, I said your f of x is what? Is your cubic. Let's label. This is your cubic. So, when you derive a cubic, you are going to find what? A parabola. That means your f prime x is what? Is a parabola. Just know it. You will see the highest degree in a parabola is 2. The degree, we see a graph, we can say this graph is a parabola by seeing the degree, the highest degree being 2. If it is 3, it's a cubic. Now, we have f prime prime, the second derivative. What is it presenting? This is a linear function. This is a linear. So, those are the key concepts that you must know. I will show you how to find all these things combined in a single video. Then we'll keep on doing examples so that you get used to them. So this was only an introduction explaining clearly this concept. Thank you for your time. Don't forget to like, share, subscribe. If you have a question, just post it on the comment section. Then I will respond to your question or make a video answering your question.